Hello, I'm Dr. Levon Hairapetyan, a business professor at Houston Baptist University. In this short video, I will demonstrate how we can use k-nearest neighbors method to estimate the value of continuous outcome. When this method is used to estimate continuous outcome, then the outcome of the new observation will be predicted based on the average of outcomes of its k-nearest neighbors in the training set. What does it mean? Let's say if I want to use 5 nearest neighbors method, so when the value of k is 5, that 5k nearest neighbor means that if I have a new observation and I want to predict or estimate the value of continuous variable, I will look at the closest 5 neighbors, and then I will average the corresponding value of all those 5 neighbors, and that will be the predicted or estimated value for the new observation. So here is a simple example which I will do in Excel when we have the average balance and then and age as a data, and then we'll try to figure out what is the estimated average balance of a new person with age of 8 years. Excuse me. So let me switch to Excel and demonstrate. So these are my observations. Currently, I have 10 customers, and for each customer, I have 2 data, 2 variables, average balance and age. So the first customer, average balance 49, age 38, and so on. Now, if I have a new customer and I know the age of that new customer, it's 28, how can I predict the average balance of this new customer based on this information? Now we'll use k-nearest method to do that. What I did, I just copied the same information here. The first thing which I have to do is I have to find the nearest neighbors of this new observation. Since the average balance will be our outcome variable, basically we have only one variable which will be used for estimation. And so that is age. So that's for calculating the closeness, and that will be the age. So here I will calculate distance of this new observation from this customer, then distance from this new observation to this customer, and so on. Since these are just numbers, then distance will be, I can just use the abs, which stands for absolute value, and calculate difference of 2 numbers. I use abs because some difference may be negative and some may be positive, but distance should be positive. That's why I'm using the abs function. So distance is 10, as you can see. Now, in order to be able to copy this down, I will make this age 13 absolute. And the reason is that all the differences here should use the same 28, because we are trying to calculate the distance from this new observation to other 10 observations. So I will copy down, and we got those distances. Now, the way k-nearest neighbor works in estimation is we have to find k-nearest neighbor. So which means we have to if k is 1, therefore we need to know what's the closest neighbor, what are the 2 closest neighbors, 3 closest neighbors, and so on. And in order to do that, we will sort this table with respect to distances. With this similar thing, when I demonstrated how we can use k-nearest neighbors method for classification. This part is identical, except just here we have only one variable. So instead of using square root for a Euclidean distance, this is just absolute. And in that video, I also showed that if the range contains formulas, then we cannot sort them. So we have to copy and save the values of those formulas. So I selected this range, go to home, copy, and then paste values. We did use this technique last time also. Now these are not formulas, just values. And what I will do, I will highlight this table and we'll go to data, sort, and I will sort based on distance to neighbors, smallest to largest, that's what I want. And I click OK. So what we got? These are the smallest distances of this neighbor. So the closest neighbor is observation number 6. The first 2 closest neighbors are 6 and 2. The first 3 closest neighbors are 6, 2, and 10. That's what I listed here. So if I use k equals to 1, then the closest neighbor is 6. If I use k equals to 2, then the closest 2 neighbors are 6 and 2. The first 2 here. For k equals to 3, the closest 3 neighbors will be 6, 2, and so on. So here I listed for each possible k, I listed all k closest neighbors to this new observation. But the ultimate goal and ultimate task was to predict the unknown average balance for this new observation. And here I did it for all possible k. So when the k is 1, the average expected or estimated balance will be 36, where for k is 2, it will be 354. Now I will just redo this next to it so you will see how I calculate it. Let's start with this 36. Which means we are considering k equals to 1. When k equals to 1, then the estimated average balance of new observation will be the same as average balance the closest observation, which is this 36. That's how I got this 36. Let me make it larger so you can see better. How about this 354? So which formula shall I come up here? Formulas are, by the way, here. You will later see in the solution, but I don't want to show just the formula. I want to explain what's the logic behind that formula. So here I want to find the expected average balance or estimated average balance if I use 2 nearest neighbors method. 2 nearest, that means those 2 nearest we know those are 6 and 2. And for these observations, the balances were 36 and 671. Therefore, the expected or calculated or estimated balance for this new observation will be average of those 2 numbers. That's the definition how we estimate the outcome of continuous variable. The outcome should be the average of the k nearest neighbors corresponding values. And this value in here is the balance. So this is how this number came from. Let's do one more and the logic is clear. So when k is 6, so I have to find the average of the closest or 6 neighbors. And these are my closest 6 neighbors. So I have to calculate average of these 6 numbers, and that's what will be in here. Average of those 6 numbers, and we can see that we got the same number exactly. Exactly the same way you calculate all expected values. So again, these are the average balance for this new observation in case when we use 1 nearest neighbor method, when 2 nearest neighbors method, 3 nearest neighbors method, and so on. So depending which nearest method you use, the average balance will be different. This is how we can calculate or estimate the outcome of a continuous variable using k nearest neighbors methods. And we did this in just plain Excel in a simple example. In the next video, I will show how we can do this using analytic solver. This concludes my short video. Have a nice day. Bye.